Hi there again. I thought I'd give another little demonstration of what you might expect to see when you first power up the design. Um, I've now fitted the LEDs, so I have two LEDs mounted in this end for the direction. I've got an LED mounted here for the manual control and an LED mounted here for USB status. So I've also connected the motor on its off-the-shelf cable, um, and I've got the manual control fitted, so plugged in over here. Okay, so let's power it up. It's running at 12 volts as you'd expect. The first thing to notice is this LED. This LED is mounted on the PCB board itself in the top left hand corner, and pulses. It's I call it like a heartbeat LED. The idea being, when you've assembled the board, you actually finished building it, you've plugged everything in, you've plugged in the pre-programmed PIC and powered the board up. This LED will pulse to let you know that the processor is up, so the processor is out of reset, and it's running the firmware, and it's also the interrupt system's working. Basically, it's just a confidence check that the processor is actually alive and up and running. If you don't want it pulsing in the box, once you're satisfied the design's working, then you can either remove the LED or remove the little resistor there, which is also board mounted as a discrete resistor. If you take that out or cut it out, then the LED will stop. The LED is obviously under software control, but there's no way of turning it off other than just removing it. Okay, this LED here is currently on, which indicates that the USB is not connected. I'll do that in another video. This is just to show sort of manual control. So while the USB is disconnected, the USB status light is on, indicating no USB connection. Okay, so in this mode we're operating manually. So if I take the manual control, I've blue tacked a pencil to the top of the motor so you can see it moving easier. If I just rotate the manual control, fairly small step size. Obviously it's a fairly long pencil, so it looks like it's moving by quite, but the actual motor's rotating by quite a small amount. You could make it smaller if you want. If I depress the center button of the manual control, this LED comes on, which means now we're in rate change mode. So if I increase the manual mode rate, note the motor is not moving at this stage. All I'm doing is increasing the motor rate. So spin that around a few times just to increase the rate, then go back to normal focus mode. So the light goes out, and now manual control is much more coarse. I'd say maybe an eighth of a turn, something like that. So that gives you a much more coarse manual control. Go back into rate change mode, spin it, reduce the rate, focus mode. Now we're back to very small steps. So the rate that you set, the rate that has been set, is remembered by the PIC microprocessor. It's stored in E2PROM. So the next time you power the device up, I'll demonstrate if I power it down, power it back up, we still operate with the same. Oh, I've done one thing here. I've increased the backlash compensation quite significant. I've put in something like 30 steps of backlash compensation, so you can, just to demonstrate the backlash compensation working. So if I'm stepping slowly in one direction and I change direction, you can see that it introduced backlash compensation. If I'm stepping counterclockwise and then I step in the opposite direction, it introduces a big 30 step increment. That backlash compensation is programmable in the driver, and once it's programmed in the driver, or once it's set in the driver, it's remembered by the PIC irrespective of whether you're connected to the computer or whether you're operating in manual control mode. So if I was to go back into the driver and set a different value, then it would be remembered by the PIC, and that would be the value that's used under PC control or manual control. I've just set an artificially large number so you can see it working. Okay, I'll do another little demo with it with it all connected to the PC. Okay, thanks for watching. Cheers.